In the rest of the videos today, I want you to have your notebook out and pen. You won't need a calculator. You're going to just follow along the video, listen to the instructions, take notes, and at the end of this lesson, you're going to just send me pictures of all the notes. Right. Now, as we go, I'm going to work through all of the problems, but I'm going to start by doing an example where I work through it and you can work through it with me. You should have those in your notebooks. And then I'll do an example. I'll start doing examples where I might do part of the problem, sort of set it up and then let you go. At times I'll be putting an example up and you should be working on it at your speed and try to beat me as I come along and start to work on it slowly with a little bit of a gap. So the goal is to get really proficient at the things that you are doing. So get those notebooks out, you won't need your calculator, but have a pencil and be ready to follow along. And we're going to go through a series of exercises just to recall all the things that you should know, but we need to solidify it and make it faster before we end up using new techniques of integration. You just have to be quick at some of this stuff, or it's going to slow you down as we move forward. Okay, so the first thing we need to review is our memory list. We're going to do differentiation. Okay, so I'm going to start writing some things down, and in your notebook, copy them down, and then you write in what you believe the result is. In other words, what is the derivative? So let me begin with, we'll start with the derivative with respect to x of x to the n. Write what that equals. Pause the video if you feel like you're getting behind. And then we're going to put in some specific examples. The derivative with respect to x of, we use x cubed, of square root of x, square root of x cubed. These are all specific examples of what is above. And okay, so I'll go back up to the top and I'll slowly fill these in. Hopefully you beat me to it. So generally, this is the power rule. That's n times x to the n minus 1. So practically speaking, it's always good multiply by the exponent and then turn around and lower it by 1. Okay, so first one should be pretty straightforward. Multiply by 3 and you end up with x squared. The second one, I have to at least think of it this way, even if I don't write it this way. That's a power of 1/2. So it's 1/2 x to the negative 1/2, which if I rewrite that in sort of more algebraic form, the 2 is in the denominator. X to the negative 1/2 means it's in the denominator and it's the square root of x. So this is probably the best form of the answer. This one is x to the 1/3. So we need the derivative of that. So that is 1/3 x to the negative 2/3. Remember, when you're subtracting fractions, let me just put this on the side. If I want to do 1/3 minus 1, I really want to make that 1/3 minus 3/3. So whatever the fraction has in the denominator, rewrite 1 in terms of that fraction, and it will get you to the answer. So once again, this is a negative exponent, so we'll end up in the denominator. So I could write that as, this will be the cube root of x squared if I want to write it in algebraic form. This is the derivative with respect to x of x to the negative 1. So the result is negative x to the negative 2, which is negative 1 over x squared. It's the best way to write the answer. Derivative with respect to x of x to the negative 2. So negative 2x to the negative 3, which is negative 2 over x cubed is the algebraic way to write that without negative exponents. This would be the derivative with respect to x of x to the negative 1/3. Therefore, negative 1/3 x to the negative 2/3. If you want to write that algebraically, negative will be a 3, 1. It looks like the cube root of x squared. So you should be comfortable with all of those. Now, many of you can go right from what's here all the way to the end, but you do need to think that step, all right? You need to be thinking about what the power is in order to use the power rule, right? Let's keep going with the memory list. All right, so I'll write another one and you try to write the answer before I do. That should be an easy one. Exponentials that with the natural base are the easiest things to do in calculus, which is why we now love the natural base. I have a different base. That would be ln of a times a to the x. Okay, let's do an example of that one. So if it was the derivative with respect to x of 5 to the x, write out what you think that is. Should be ln of 5 times 5 to the x. So that's a concrete example of that form. Let's go ahead and keep going. Let's do the derivative with respect to x of sine of x. Fill in a couple of these. And then we'll do their reciprocals. Of, let's say that would be secant of x. Okay. So let's do this. So we should have these memorized. So this, hopefully you remembered, is the basic one. We start with the cosine, the sine, because it's derivative. It is the cosine. The derivative of the cosine is the negative of the sine of x. And that's where our little memory wheel, I said sine goes to cosine, which goes to negative sine, which goes to negative cosine and back again. If we're taking derivatives, we work our way around. So that's the memory wheel is useful for the sine cosine relationships. All right, and then we're getting into our tangents and cotangents. Okay, so the tangent is secant squared of x. Likewise, the cotangent is negative cosecant squared of x. Now these were a little bit trickier. The secant was the secant x tan x. The cosecant was negative cosecant of x cotangent of x. And remember, these factors are interchangeable. They can be in either order, so you can remember it either way. Remember, we had two ways to remember this. If I write tan secant secant, the tangent leads to the secant times the secant. If I start with a secant, it would equal the secant times the tangent. If I start with the second secant as I go around, then it would just be tangent secant. So it's the same thing, and those were all with a positive. And if we want to remember the other one, you can start with, if you remember that the cotangent leads to a double cosecant with a negative sign, put a negative in the middle of all of that, then you can start with, well, let's start with the cotangent leads to the cosecant times another cosecant, as we would expect. But then if we're trying to remember what the cosecant does, you can stay on the same circle and take a cosecant times a cotangent and always throw a negative in. So that's how we remember those. Okay. Now the rest on our memory list are inverse functions. Okay. Write in what you think it is. The answer is actually that. Okay. Now it's an aside, when we get to integration, I could have written that, and that is also 1 over x, and that's important because when we get to antiderivatives, we will be able to go back and we will want to use ln of absolute value of x as our antiderivative. Okay, another one. Let's get into our trig ones. In fact, I'll write all 3 of the primary ones, the ones that show up on your calculator. See if you can write those in. I'm going to start at the bottom of that list. It's actually the simplest. The next easiest is the inverse sine. And the inverse cosine is very similar to the inverse sine. A little crowded here, so let me just box these answers in so they don't run into each other. All right, and you might notice a little pattern here. In the textbook, they actually switch those 2 terms because x squared plus 1 and 1 plus x squared are the same. I just like to memorize it this way because then they look more similar to each other. All I need to do to go up from the tangent, if I start with an inverse tangent, I can add a square root, square root over the denominator and change the plus to a minus. And then to go from inverse sine to inverse cosine, I just add an extra negative and I can use those. Okay, so that's the memory list for differentiation.